Hi grade 12s and welcome. In this video we're going to learn about angle of elevation and angle of depression, which is a subtopic of trigonometry, especially in application problems. We're looking at angle of elevation and depression. So what are elevation angles and what are depression angles? So if you are on the ship and you're looking on top of a tower, right? So this will become the angle of elevation. Elevation means to look up, right? Elevation, and depression means to look down. So this is example, if you are sitting here, right, and you're observing someone on the ship over here, right? So this is your line of sight, right? So your angle of depression is right here. This is theta angle. So that's angle of depression. Now notice that the angle of depression is just outside this triangle. So there's a tower here, maybe a lighthouse or something, and you're looking down. So now, according to the alternate angle theory, remember, you can form a Z, right? And when you form a Z, you can take an alternate angle because this is parallel to the line of sight in the ground, right? Ground level is parallel to the line of sight. So that's theta angle, that's also theta angle. Now you can apply trigonometry here. Remember, this is the angle of elevation. If this person is looking up to that person, that's elevation angle, and depression angle. So you can make the angle of elevation equal to the you can make the angle of depression equal to the angle of elevation by taking an alternate angles. Now after you do that, you observe from this theta angle, that's the opposite. Then you can use SOHCAHTOA, right? That's the opposite. This is the adjacent, right? That's the adjacent side, and this is always the hypotenuse, the longest side, directly opposite the 90 degrees. Now since we understand what is angle of depression and angle of elevation, remember this is the elevation angle, right? That's the angle sign, okay? Angle of depression, angle of elevation. Now let us look at some example. It's nice to draw a diagram because these are story sums. A man stands 20 meters away from a tree. So assuming that this is a tree, right? Right, this is the tree here, and the man is standing here 20 meters away from the tree. Okay, so let's just take this tree branches and the leaves out. So let's just say this is the height of the tree, right? And he stands 20 meters away from the tree. He looks up to the top of the tree. So there's a top of the tree at an angle of elevation of 60 degrees. So he's looking up at 60-degree angle. So elevation angle, you can see. So that is 60 degrees inside. Now how tall is the tree? So how tall is the tree is to find the height. So we're going to say we have opposite, adjacent. We want to find the opposite, but we have the adjacent. Opposite, adjacent according to SOHCAHTOA. First of all, we don't have the hypotenuse, right? If we don't have the hypotenuse straight away, h and h falls off, so we only stuck with tan. So we will use tan identity to solve this, right? So we say tan 60 degrees is equal to, sorry, tan ratio. Tan 60 is equal to h over 20, right? And then we cross multiply, h is equal to 20 tan 60, right? And we know tan of 60 is a special angle. And what is the special angle? You can use the 30 60 90 triangle, right? We know 30 degrees is here, 1 2, sine of 30 is half, that's root 3. So tan of 60 is root 3 over 1, so 20 root 3. You can type this on the calculator and get a final answer. Let's type it out. So 20 tan 3, 20 tan 60. When we do 20 tan 60, we're getting 20 root 3, and that is 34.6 meters tall. 34.64. 34.64 meters tall. How tall is the tree? So 34.64 meters. Right. I hope you guys are understanding. Purely application using right angle triangles. So you just use SOHCAHTOA. From the top of a 100-meter lighthouse, so this is a nice classical example, right? So there's a lighthouse here, right? And that's 100 meters. The angle of depression to a boat, so there's a boat at sea here, right? And is 30 degrees. So remember, 30 degrees is an angle outside the triangle. So I'll show you where the angle of depression is, right? Angle of depression will be here. So the person is here on the top of the lighthouse. The angle of depression is here, which is 30 degrees, right? He observes a boat, right? So 30 degrees. What is the distance from the boat to the base of the lighthouse? So this is the base of the lighthouse. So what's the distance between the boat to there? Right? So we can just call this x and solve for x. Now remember to take an alternate angle. So that 30 degrees, we see a z here, right? And this is 30 degrees. Again, we have opposite adjacent, so tan 30 is equal to 100 over x. Now if you cross multiply, you get x tan 30 is equal to 100. We know what is tan of 30. Tan of 30 is 1 over root 3, because opposite over adjacent using the 30-60 triangle. So x over root 3 is equal to 100. So x is equal to 100 square root of 3 by cross multiplying. So what is 100 root 3? So let's type 100 square root of 3. 173.21 173.21 meters. So that's the distance from the base of the lighthouse to the boat. Let's move the boat closer here. Right, that's where the boat is. Right, so I hope you guys understood that problem. Now comes a little bit more challenging problem. A person observes a tower from a point, right? So a person observes a tower from a point. So there's a point here, there's a person, right? And he observes a tower. So there's the tower here, right? So let's move this tower a little bit closer, right? The angle of elevation to the top of the tower is 45 degrees. So 45 degrees. So this person is looking up to the top of the tower at an angle of 45 degrees. Now this is 45 degrees. After walking 30 meters towards the tower, so now this person walks 30 meters towards the tower, right? Now obviously when he's walking towards the tower, he needs to look a little bit more up, so his angle of elevation will basically increase. So now it becomes 60 degrees. If you read the story, elevation becomes 60 degrees there. Find the height of the tower, right? So very limited information, but it is possible to solve it. Now how do we solve this? First we start with the 45-degree triangle. Now in a 45-degree triangle, if you're making this to be h, or let's call it x, okay, it's fine, let's call it h, because that's the height of the tower. It's a 45-degree triangle. Initially, you know, in a 45-degree triangle we have adjacent sides equal. So this entire distance from there, this yellow distance here, the base, is also h. The entire distance is h, okay, from the 45-degree triangle, h and h. So if you take away 30 from h, you are left with, now example, just say if this was 100 and this is 30 meters. If he walked 30 meters, then obviously he's got 70 meters left. How did we get 70? 100 minus 30. So now this is h meters, so you say h minus 30, right? Now h minus 30, and you got h, so you got opposite adjacent, you just use tan again, right? So you're going to say tan 60 is equal to h over h minus 30, right? And now what is tan of 60? Tan of 60, we drew this triangle. Tan of 60 is root 3 over 1, so we know tan 60 is root 3. So we have a root 3 here is equal to h over h minus 30. Now we're going to cross multiply and solve. Now remember, when you cross multiply, there are two terms here, okay, and just one term here. So we know root 3 times h is root 3h. Root 3 times 30 is minus 30 root 3. I hope you understood that. Root 3 times 30 is 30 root 3. And 1 times h is h. Now this is like a linear equation. You got h on one side and you got h on the other side. Bring the h over and take this number over. So you got root 3h minus h equals 30 root 3. Now you can factor out the h, right, because that's the HCF. So you're left with root 3 minus 1 is equal to 30 root 3. Now carry on solving. Say h is equal to 30 root 3 divided by root 3 minus 1. Okay, now some people, you forgot how to rationalize, so we're going to rationalize this by multiplying by the conjugate. Root 3 plus 1 divided by root 3 plus 1. Why we multiply by the conjugate? Because we want to rationalize, and we know that a squared minus b squared is equal to a plus b into a minus b. So we're going to apply this rule in here. Okay, we're going to apply this rule in this problem here. Let me just block this out so you don't forget this rule here. Right, now we got 30 root 3 times root 3. Root 3 times root 3 is 3. 3 times 30 is 90. Plus 30 root 3 times 1 is 30 root 3 divided by root 3 times root 3 is 3. I'm using a squared minus b squared. You can clearly see you got a plus b, a minus b. You got a minus b, a plus b. And then 1 squared is 1 minus 1. So what do we have? We have 90 plus 30 root 3 divided by 2. 90 divided by 2 is 45. 30 divided by 2 is 15, square root of 3. And now if you type this into the calculator, 45 plus 15 square root of 3, what's the answer? The answer is 70.98. So approximately, we can just say 71 meters, right? So approximately the height of the tower is 71 meters. Now if you go back here, remember this is the answer that we had. Now if you're going to try and type this on the calculator, you definitely get this. Let's double check that. Right, so if you type that on the calculator, like 30 root 3 divided by root 3 minus 1. Aha, you're a genius. Excellent. Right guys, I hope you understood that. All the best.